Hi folks, Damon here, and today I want to take you on a tour of data analytics on AWS, and I want to show you how when you upload, a big raw TSV file to S3, you can use Athena to query and explore that data, convert it into an optimized data set, and then use EMR Studio and Redshift to also query that data set and do some analysis on it. So let's get started. We're going to go with a giant CSV that we want to take a look at. So Washington Post has a DEA pain pills database. That's a pretty interesting data set. It is 6.5 gigs zipped and 75 gigs unzipped. And it's just a fairly standard TSV. So if we take a look in our S3 bucket at that, what we'll see is those different files, and you can see I've got my TSV file there. There's the gzipped version at 6.5 gigs and the full TSV there. So pretty big TSV file, and this is not uncommon to have this dropped on you as a data analyst. So let's see how we can use Athena to go ahead and query this data set. So we're going to go and create an external table in Athena. I've already got the schema of that TSV file in here. So let me just flip over to Athena, and I'll go ahead and say create external table. And I'll point to that TSV file, and then I point to where that file is on S3 and tell Athena that it is tab delimited. So I go ahead, run that query, and that's going to go ahead and create a table in the glue data catalog of that TSV file. Let me go ahead and do that for the gzipped version as well. I've got another create table statement down here, and the main difference is it'll just be a different location on S3, and I will specify the compression type there as well. So I'll go ahead, I'll run that query, and now I've got two different tables in here. So let's see what this looks like when we actually go ahead and query the tables. I can just do a select star from that TSV data set, and we'll limit that by 100. When I run that query, Athena communicates with the glue data catalog to learn about the schema of the table and where it is on S3. And then Athena goes out to S3, reads that file, pulls it in, and then displays it here in the Athena console. So you can see that ran in under a second, only scanned 6 megabytes of data. So with Athena, you pay for the amount of data that you scan. And so that's something to keep in mind as you go through this. So that is the TSV file. It only scanned 6 megs of it because it just had to read that first chunk of it. Let's see what happens if we do that on the gzip one as well. So if I go ahead and run this query, you can see again ran super quick because we're just pulling in 100 records, but it only scanned 50 KB this time. That's because it's using that compressed version of the file. So you pay a lot less when you're compressing things, but at the same time, there are some other trade-offs there as well. So let's do a quick count of that data set just to see what that looks like. So we'll do a select count star from the TSV file. And again, this is going out to S3 and reading in that whole TSV file and iterating over all the rows, and then doing a count of it. So that took about 6.5 seconds, and you can see it did scan all of that data. So maybe we do a count star over the gzip version, and again, this is going to go out to S3, start reading in that gzip file and give a count of that gzip file. However, gzip is not a splittable format. So what ends up happening, even though Athena is a distributed query engine, because gzip is not splittable, it can only have one process, literally one CPU dedicated to unzipping that file, right? And so what you're going to find is that this is a 6 gig file. So now we have to have one process that's reading through that whole file and unzipping it, and that's going to slow this down quite a bit. In fact, this query here is going to take almost 5 minutes just because it takes a while to unzip a 6 gig file into 75 gigs and then do the count, right? So that's one thing to keep in mind as you're looking at data sets on S3 when you're browsing through them, is there is a different trade-offs between the size of the files you have, the compression type you use, and the format of the files. And this is one area where using a columnar binary format like Apache Parquet can be really beneficial, because with CSV or JSON, while that's really helpful for humans to be able to open up and read, it's not great for machines. And Parquet is nice because it is a columnar format. So if you're only pulling out one column, it only has to scan that one column in the file. But there's also a bunch of metadata in the Parquet files too. And that metadata includes the number of records in the Parquet file. It includes the maximum, minimum of different columns. And so when you run queries over the Parquet data set, it can be a lot faster. So let's cancel this here. And what I can do with Athena has the ability to create table as select. So I can actually do a create table of this data set, I can say create table, and I'll add a parquet to it, and I can put my S3 location where I want the resulting parquet files to be put, and then I just say as select star from the TSV data set. So Athena is going to take that TSV file, open it up, convert it all to parquet, and write it out to S3 for me. I've already done this, so this query can take a couple minutes to run, just because it's doing all that conversion for you. But if I do an S3 ls of that location on S3, what we'll see is we get back 21 files that are around 120 megs each and total 2.5 gigabytes. So Athena did a bit of optimization for me already. 128 megabytes is kind of a good file size when you're working with Parquet, to split data up into. And of course, that's entirely dependent on your data set. If you've got a 50 terabyte data set, you might want to use bigger Parquet files. But in general, 128 megs is a pretty good starting point. So we've already split up between 128 megs. We've got those 21 files. And now if I go back to Athena and do a count star of that Parquet data set, what we'll see is that'll come back again pretty quickly. That actually returned in less than a second, and we only scanned no data. How is that even possible? Well, with Parquet, like I said, there's that metadata in the files. And so what happened is Athena went out to S3, opened up those 21 Parquet files, but just the header, and then it read the number of rows from that header, and then summed that up and gave us the answer. So it didn't have to scan any actual data, which is really nice. So any sort of aggregate queries or anything like that you're doing with Athena on Parquet data, it can be really, really efficient with it. Say, for example, you want to just do a count of the reporter state. Again, that ran in 2 seconds and only scanned 300 KB of data, right? Because it just looked into those files. It had to pull out the state information, but then it could just sum up the number of records that are in the Parquet file, which is really, really nice. So that query can be optimized really well. And this is just something to keep in mind as you're working with analytics on S3 is there's a lot of optimizations that can go into the data that you store on S3. So it's not just the file format. You can put things in different partitions, which are kind of like folders for different categories of data. You can even sort the data in the file as you're writing the data out to the file. So depending on what your use case is, depending on the type of queries that you have, you may want to change how data gets written into S3. So with Athena, though, it's really nice. You can do this, create table as select. There's unload functionality in Athena. So you can do a lot of, data munging in Athena, which is really, really nice. Now, let's say we want to switch over to EMR and use Spark to do some analysis of this data. Before I do that, let's take a quick look at the Glue console. I mentioned when I did that create table in Athena, it added the table in the Glue data catalog. So here you can see, here's my Glue data catalog and all my tables there. And there's my 3 tables there pointing to my location on S3. If I click on that pain pills TSV, you can see there's the location again, the input format, the serializer, deserializer, and any parameters for that table. You can also edit the schema in here. So I can go in. If I know this is an integer and maybe I need to change it, I can go ahead and change that in the data catalog or add a comment. This is the one you want in the data catalog. You can do that too. And one common use case I see for this is people will drop some JSON metadata in here, some machine data that if they have a dashboard that's fronting the Glue data catalog, they can put business metadata in here, for example. So I can go ahead and I can save that. And one nice thing about Glue too is it maintains all the old versions of the table. So I can go back here and I can actually switch between a different version of that table if I want to. So that is the Glue data catalog. This is what helps enable all these other different systems to query the data from S3. So let's hop over to EMR. I've actually got an EMR cluster already started here, but let me just show you what it would take to create a cluster here. So there's my cluster. I pick the release I want. The 5 series is Hadoop 2. The 6. Series is Hadoop 3. And then I can say, use Spark. And then there's a checkbox here to use the Glue data catalog for table metadata. So this tells EMR to use Glue instead of a Hive data catalog for looking up tables and schemas and things like that. And then you can also enable this EMR managed autoscaling, and this will scale the cluster nodes based on the workload. So every 5 to 10 seconds, EMR will check the metrics on the cluster and see if it needs to increase the amount of core nodes or task nodes. So I've already got my demo cluster here. And we can see I'm just running a couple of C5, 2XL and 4XL there, and I've got glue enabled and EMR managed scaling enabled. So I'm going to use EMR Studio, and EMR Studio is also a really nice way to manage your EMR clusters. So I can go in here and I can look at my clusters, and I can actually launch application UIs directly from EMR Studio. So when I click on that Spark history server, that launches a history server for me, and I don't have to SSH into the cluster or do any sort of proxying. I've got my Spark history server with all my jobs that I ran here, right, accessible from my browser. So that is really convenient for me to be able to launch these different UIs from here. But what I've got in here are different workspaces. So I've got this Scratch workspace here, and just where I do some demo stuff. And with that, when you launch into the workspace, you connect to a cluster. So right now you can see I'm connected to this demo cluster glue. If I had an EMR cluster on EKS, I could connect to there too. Or if I wanted to detach from this cluster and connect to another one, I could do that as well. And then I can fire up Python 3, PySpark, Spark Scala, and Spark R notebooks. And if I had custom ones, I could do a custom kernel as well. So you saw I had a bunch of Julia clusters in my account. I've been experimenting with having a Julia kernel in EMR Studio, so you can do that as well. But I'm just going to use PySpark here. So let me flip over to my demo. One other thing with EMR Studio, you can connect it to GitHub or Bitbucket or other different Git repositories, and that shows up in your file browser here. So I've got my Git repository here that's got some of the data that I work on a regular basis. And when I deploy to this Git repository, it actually automatically deploys to notebooks.decort.dev, which is just my fun auto notebooks place. So you can see there's my sleep analysis right there, and that's the notebook that I have back in my my environment here. So let's read data from the glue tables using PySpark. So we'll just do a quick show tables first. I might need to, nope, I'm good. I'm already connected. Sweet. So you can see there's my 3 tables in my database, and these are the 2 that I created, or the 3 that I created inside of Athena. And now I can just run Spark SQL and go ahead and query these tables. So I'll just do a select, name and state from that Parquet data set. And again, what's happening here is my notebook is going to the EMR cluster. The EMR cluster goes to Glue, queries the data catalog to see where this Parquet table lives, and then it goes out to S3, it reads in those files and gives me the results back. So I can do simple queries here as well, where I can maybe aggregate by buyer state and do all this kind of standard SQL stuff. And I can write Spark SQL like that. But there's another thing I can do too that I'll show a little bit later. So I want to do some charts. So I'm going to install Plotly on this notebook. I already did that, and that goes and downloads it and installs it right in the notebook here. And then just to make sure Plotly is working, I do a quick graph just to say, okay, cool, Plotly is installed and it's working. And then there's a %% help function you can use in the notebook, and that shows you some different functions you can use, some different magics you can use. And the 2 that I'm interested in are the SQL magic here. So I can do a SQL-O tables and then run a query, and it takes that query and exports it as a pandas data frame in the local Python context in the notebook. And if I wanted to, I could even modify that data frame and then send it back to Spark if I wanted to. So pretty useful there to be able to do that. If I needed to change some of the Spark settings, I could do that too, but we're not going to do that right now. We're just going to run some SQL and output it to a local pandas data frame. So here's my %% SQL. I'll output that to state counts, and that'll go ahead and that'll run. And then that will be available to my local context. So you can see down here below in this local context, I'm going to use Plotly to draw a bar chart, and my X value will be the state count from up there, and my Y value will be the actual state. And that's almost done right there. So let's go ahead and hit enter. And as soon as that's done, we should be able to graph that. I do have auto scaling enabled on my cluster, or AMR managed scaling. And it doesn't look like it's doing anything yet because I've only run a couple different queries. But you can see here, if it was resizing, it would be resizing those 2 groups right there. So that's pretty cool that it can keep an eye on the cluster. If it needs to scale up, it can. If it needs to scale down, it can. Looks like that ran, and here is my bar chart of count of buyers per state, and you can see there's California and Texas and Florida as the top states right there. So let's dive in and see what it looks like for over time for each state. I'm going to kind of skip over some of this because I was just doing some exploratory analysis. There was some bad data that I had to filter out, so I filtered that out. You can see there's the buyer state, there's a header in there, and another random value. So I filtered that out, and then figured out my SQL and brought it into a local pandas data frame again. So there's my state counts by year data frame. I'm going to do just a quick NP unique on that, a NumPy unique, just to make sure I've got the data that I expect. And I'll look at what the data is for Washington State, and we can see there's my year and there's my count. So everything looks pretty cool here. So I'm going to take this and actually draw a line chart. I want to highlight a few states that we're interested in. So let's look at those top 3. And when that draws the line chart, you can see all the other states are grayed out down there. But now we have this interactive graph from Plotly that shows us how those top 3 states look. If I want to zoom into a different state, say maybe Connecticut, I can actually double click and that'll show me the Connecticut stats there. Or if I want to, I can actually add another highlight state up here. So I can say, okay, let's do Washington. Well, highlight that Washington state up there. And then you can see that's now highlighted down there. So I can kind of compare them iteratively in this demo. So that is using a Jupyter Notebook on EMR Studio to query the data in S3 that we created in Athena and converted in Athena. So that's how you can kind of take this data and move it into different systems. But let's do one more system just for the fun of it. So I want to show how to query that data in Redshift as well. So let me skip down here, and in Redshift, there's Redshift Spectrum, and you can create a Spectrum schema that references the Glue data catalog. So I've got Redshift here, and there's a query editor inside of Redshift. I'm already connected to the database. You can see I've got no tables in my public schema, and so what I'm going to do, I'm going to create this external schema here. And when I say from data catalog, that's going to point to the Glue data catalog. So now I've got my Spectrum schema. And if I switch over to that Spectrum schema, you can see I've got my 3 different tables there. And now I can write queries in here as well. So I can just say select star limit 10. And again, this is just going out to Glue, querying Glue for the format of the data and where it lives on S3, querying the data from S3, pulling it back into the Redshift engine, and then displaying it here for me. So I can do the same aggregate queries that I was doing before, and Redshift will take care of going out and pulling in the data that it needs to and running this query. And again, this is pretty fast, right? This took 2 seconds to go ahead and pull that query and execute it in Redshift. So one common use case is pulling data into Redshift from S3. So if I wanted to, I could aggregate the data as part of this ingest process and then create a new table in S3. So I'm just going to say create table ag data as select reporter state count star from that Parquet data set, and I'll go ahead and I'll run that. And again, that'll be pretty quick, and that'll create me a new table in my public schema. Now you can see there's my ag data table right there. So if I just go ahead and preview that data, now I can use this data in Redshift. I can modify it if I want it to. I can, enrich it or do whatever I want to. And now I have this data in Redshift. And so yeah, pretty useful from that perspective. Another use case for this is maybe you have live data that you want in Redshift, but you want to be able to access and join historical data with it as well. So you've got 7 years of data in Redshift, but that's already, a petabyte, and you don't want to have to store 50 years of data in Redshift or something like that. So you could actually put that historical data on S3 and then join it with the data in Redshift if you need to. So that's kind of a quick intro to dropping some data on S3 and integrating it with Athena and Glue and EMR and Redshift. But just wanted to show that and how you can kind of take that data, move it in, out, and around of S3, and some of the different use cases connected with it. So thanks for joining, and hope you enjoyed it. Let me know if there's anything else you want to see. So thank you. Have a good one.